Before taking a physics class, most people probably do not understand or even think about the areas in their lives that physics are used. Almost everything. Physics is involved in every type of motion. We see it in washing machines, cars, pushing a grocery cart, and so much more. There is even physics in stationary objects. Physics surrounds our lives, and one area that people are able to find many different elements of physics is in sports. Specifically, the sport of basketball consists of numerous quantities, laws, terms, and even equations that are used in physics as well. I will discuss the speed, velocity, acceleration, projectile motion, backspin, hang time, friction, air resistance, drag, and propulsion used in basketball. There are many different aspects to basketball, and the most commonly thought of is probably shooting the basketball. We first think of terms such as speed, velocity, acceleration, and projectile motion when we think of this action. Speed is defined as the rate at which an object moves. As we know, the quicker the object moves, the greater speed it has. And the slower it moves, the lower speed it has. The speed involved in a basketball shot involves both the speed of the basketball and the speed of the individual. For a beneficial shot, the shooter wants to be set, or stationary, in their position. This gives them more control. The motion of their body as they move into their shot should be at a constant speed. As they are moving into the shot, they are actually producing force to be exerted on the basketball. As stated in the law of conservation of energy in physics, energy can neither be created nor destroyed. Energy can only be transferred between objects or transformed from one form to the other. The two forms of energy are kinetic energy and potential energy. In this case, energy is being transferred from the shooter to the basketball. The speed of the basketball will then depend on how much force the shooter applies to it. Force is basically the power used in physical activity or motion. Velocity is another term used when an individual takes a shot in a basketball game. Velocity is defined as speed in a certain direction. Velocity is used when shooting a basketball because a good shot will be the perfect speed and in the perfect direction. Mastering the force to shoot the ball with and the exact direction is very important for a good shooter. A shooter also jumps when taking a shot, which is another way we see velocity in this part of basketball. Some shooters may jump higher, meaning they are using more force and have a higher velocity. Most also jump somewhat forward. However, those who jump significantly forward normally do not have a very good shot. It is important for shooters to land very close to the spot in which they were before the jump. Acceleration is another element of physics that is seen when shooting the ball. Acceleration is defined as the rate of change in velocity per unit of time. So it is basically how quickly or slowly a person or object speeds up or slows down. The shooter develops force by combining acceleration and mass. As we know, the formula for force is mass times acceleration, stated in Newton's second law of motion. In this case scenario, the mass is the basketball. The player has to use the correct amount of force to act on the ball in order to make it accelerate at the appropriate speed and in the appropriate direction. Great shooters also put backspin on the ball to help them have something called shooter's touch. When a spinning object comes into contact with something, it will likely bounce in the direction that it is rotating. That is why players try to put backspin or backwards rotation on the ball. If the shot is a little off and hits the back of the rim or the backboard, there is a very good chance that, with backspin, it will still go into the basket. If the spin on the ball were sideways, the ball would most likely bounce away from the goal. We see this topic in Normani's article that I've cited. Last, when discussing the physics of a shot in basketball, projectile motion is a key component. Projectile motion is the curved path along the line in which an object moves under the action of only gravity. As I mentioned above, the ball accelerates when leaving the player's hand, traveling at a specific speed and in a specific direction until it reaches its maximum height. There, gravity takes over, and the ball begins to travel back down along this trajectory path and into the basket. Another key component of basketball is passing, and physics is of course involved in this as well. Speed, velocity, acceleration, and projectile motion are all also used with this specific skill. Different passes require different speeds. A chest pass, for example, is normally thrown at a high speed. In contrast, when throwing a lob pass to a post player, it is more beneficial to throw the ball with a lower speed. Velocity is used in passing because different types of passes are thrown in different directions. A bounce pass is thrown low, making it bounce once before reaching the waist of the teammate. A chest pass is thrown to their chest, and a lob pass is thrown upwards to travel over a defender. Projectile motion is also seen here as the ball travels in a curved path to the other teammate. The path the ball travels may look like a straight line, especially in a chest pass. However, it's not. A quote from the article titled Physics in Basketball states, "It's actually a downward parabola because gravity continuously acts on the ball. The x-coordinate force is the force put on the ball by the player's hands. The y-coordinate force is the force due to gravity, which is the acceleration equal to negative 9.8 meters per second per second." Dribbling is the other way, besides passing, to move the ball on the court. Velocity is a key component to recognize in dribbling because the direction in which the player dribbles the ball is important. If he or she pushes the ball straight down, it will either hit his or her feet, or he or she will not be able to travel a far distance with that dribble. In order to maximize a dribble and to be efficient, a player should push the ball out in front of them. Acceleration is seen in dribbling when the player's hand pushes the ball towards the ground, creating kinetic energy. When the ball bounces off the ground and is traveling back towards the player's hand, it gains potential energy. When dribbling a basketball, we also see Newton's third law of motion. It states, "For every action, there is an equal and opposite reaction." This explains how the ball travels downward to the ground and returns back to the hand with a force equal to when it left, but in the opposite direction. Running, jumping, and sliding are all very important to the game of basketball as well. The players obviously have to run up and down the court, so here the term propulsion comes to mind. Propulsion is the force applied by the muscles for a forward motion causing acceleration. This definition is from the article titled Forces Involved During Running. Air resistance obviously creates drag, which is the force that acts against the player running and causes them to slow down. With running, we again see Newton's third law involving equal but opposite reactions. As the player's foot pushes down into the ground pushes back up with an equal but opposite force to propel them forward. Jumping is a very important component of basketball. With this action, hang time, which is the entire time the athlete spends in the air, becomes a factor. The more force he or she pushes off the ground with will cause him or her to jump higher and therefore have a greater hang time. Sometimes it looks as if the player stops in midair at the peak of his or her jump. A quote from Normani's article states, "This is a consequence of projectile motion. When an object is thrown in the air, it will spend a large percentage of time in the top part of the throw. The same concept applies to a player when he or she jumps. However, gravity then begins to take over and pull him or her back down to the ground." When considering the equipment used in basketball, physics is again used to explain the reasons and uses for certain materials. For example, the basketball used in the game needs to have high air pressure so that the ball is able to bounce. If it does not have enough air pressure, it will not have enough air particles to push off of the ground and cause the ball to bounce back up. Similarly, if it has too high of air pressure, the ball will bounce back up with too great of a force and be very difficult for the players to control. Another piece of equipment important in basketball games is the shoes the players wear. Basketball is a game of sprinting, slowing down, sliding, stopping, and quick changes in directions. It is vital for the basketball shoes to have good traction, causing friction between the shoe and the court. Friction is defined as the forces exerted by a surface as an object moves across it or makes an effort to move across it. This definition is from the article titled Types of Forces. Players want good traction between their shoes and the court. Static friction is the force that acts on non-moving objects. A quote from the article Physics in Basketball states, "Static friction allows a player to stop and turn without sliding because the static friction is greater than the sliding friction." Overall, physics is used in all areas of the sport of basketball. It is used without the ball in running, jumping, and playing defense. It is used with the ball in shooting, passing, and dribbling. And finally, it is also used in the equipment, such as a basketball or the player's shoes. Physics can help people understand the sport of basketball better and can also help individuals become better players by understanding the logic behind their sport.